So number three, the first part is just going to be like, okay, those percentages we used last week, they're good under certain situations, specific situations. What we're going to learn today works under any situation. All right, so if we look at number three, we have a normal population, meaning it is roughly bell-shaped. So it would look like a bell curve. And then we have a mean of 28, so 28 would go in the middle, and a standard deviation of 5. So we would add that number 5 over 3 times. So 28 plus 5, 33 plus 5, 38 plus 5, 43. And then we would subtract that number, 23, 18, and 13. So last week, on the classwork and on the Delta math thing, every single number that would have showed up last week would have been one of those numbers on the number line. It would have been 33. It would have been 38. What percent is less than 43? What percent is greater than 23? What percent is between 28 and 38? It would have been one of those specific numbers already on the number line. But our number today, what percent are greater than 31? Well, where is 31? 31 is about right here. So can we use what we learned last week to find this percentage? And the answer is kind of, because I'm looking for everything greater than 31. So that would be all of this area over here to the right of 31. And I know to the right of 0.43 or to the right of 43 would be 0.15. Between 38 and 43 would be 2.35. Between 33 and 38 would be 13.5. But then between 28 and 33 would be 34. So how much of that 34% are we using? I don't really know. So we can get to a really close estimate using the 34, 13.5, 2.35, and 0.15, but we really have no idea like how much of that 34% are we using, because the number's not exactly on 28. It's not exactly on 33. It's in between those two numbers. So that's why we're learning what we are learning today. So that's all in number three. We'll come back and finish number three in just a little bit. Z-score notes and Z-score formula. What is the formula for Z-scores? 3. There's 3. Z-score formula. We get Z equals, we'll talk about what a Z-score is in just a second, X minus X bar divided by the standard deviation. And so divided by the standard deviation. So if you don't know what those letters represent, like X bar is the average. Okay, X bar is the average or the mean. This symbol down here is the standard deviation. So if you don't know what those things are, maybe you write them down somewhere. You should know what they are by now. We've seen them lots of times last week. And what is X? X is actually the number we're interested in. So if we go back to number 31, number 3, our X value in number 3 would be the 31. What percent is greater than 31? That's the number that we are interested in. So that's the formula. Now, what is a Z-score? You're like, Z-score? That sounds kind of weird. What is a Z-score? A Z-score tells us how many standard deviations, how many standard deviations we are from the mean. How many standard deviations we are from the mean. So that number that we're interested in. So if we found a Z-score for number 3, it would tell me how many standard deviations 31 is away from the mean. And like, what do you mean? Like, okay, let's look at a bell curve very quickly. And we had Z-scores. Let's say we labeled this bell curve with Z-scores. We're going to put Z-scores on here. How far is the average away from the average? Well, they're the same number, right? So the average would have a Z-score of 0. the average would have a z-score of 0. What about this number up here? Like we add the standard deviation. So we take the average and we add one standard deviation. That would be a z-score of 1 because it's one standard deviation away from the mean. In our example number 3, the standard deviation was 5. So 28 plus 5, 33. 33 would have a z-score of 1. 38 would have a z-score of 2. And 43 would have a z-score of 3. Those numbers are positive because they're greater than the mean. What about the numbers on the other side of the mean?
-1 and -2.
Yeah, so they would just be negative. So if we go back to number 3 and we were to talk about z-scores is just standard deviations. How many standard deviations are we away from the mean? That's what we call the z-score. Why is it called the z-score? I don't know. Whoever came up with it, probably last name was Z or something. I really don't know the answer to that question. But we call it a z-score, but it really just tells me how far away are we from the mean in terms of standard deviations. So number 1, can we find the z-score? So we have a certain brand of batteries. That certain brand has a mean life of 52. So if we were to write out what all of these numbers are, X bar would equal 52, has a standard deviation of 8. So sigma, our standard deviation is equal to 8. Find the z-score that corresponds to 62 hours. So the number we're interested in, X, is 62. So now we can use that information. How far is 62 away from the average in terms of standard deviations? So my z-score, I'm going to write the formula over so we can see it one more time. X minus X bar over the standard deviation. X is 62 minus the average is 52 divided by the standard deviation is 8. So if you think about this, how far is 62 away from 52? 10, right? But in terms of standard deviations, one standard deviation is 8. So if we're 10 away, that's a little bit more than one standard deviation. So my z-score should be 1 point something. If we were 16 away, my z-score would be 2 because that would be 2 standard deviations away. So if the standard deviation changes, the z-score is going to change as well. So it does tell us how far away from the average we are, not just how far away from the average we are, but how many standard deviations away from the average we are. And that's 1.25 in this case. So what does this mean? This means that 62 hours is 1.25. I'm going to abbreviate standard deviations. I hope you're okay with that. 62 hours is 1.25 standard deviations. And since we got a positive number, we also can say not only away from the average, but above the average. And we can even write the average if we want. 62 hours is 1.25 standard deviations above, this way, the average of 52. What can we use z-scores for? Just z-scores specifically. We can use z-scores to compare things that we might not originally be able to compare. So I'm going to read this question to you. See if you can answer this question. See if you can answer this question. Maybe you're going to college. Maybe you want to go to college. So you plan on taking the SAT. And maybe you also plan on taking the ACT. And if you know anything about those tests, the SAT is scored on a scale from 0 to 1600. The ACT is scored on a scale from 0 to 36. This person made an 1170 on the SAT and a 26 on the ACT. Which test did he do better on? Like, we can't compare them, right? Because the way they're graded is completely different. But obviously, if I were to send these two scores to a college admissions office, they would look at the 1170 and say, that's pretty good. Or maybe that's not so good. But they would also know something about that 26. But as a student in high school, which one of those two would you want to send to the college that you're trying to get into? The 26. The 26? Maybe. How do we know? Well, here's what we can do. We can actually find the z-scores and see, once we find the z-scores, we can see where we fall on this bell curve. And the further right we are, the better score we have. So if I find the two z-scores, the one with the highest z-score is going to be the test that we did the best on. The one that with the lowest z-score is going to be the one that we did the worst on. So we actually have to find two z-scores, one for the SAT and one for the ACT. The SAT, the score in question is 1170. The average is a 1050, and the standard deviation is 90. The ACT, the score in question is a 26. The average is a 22, and the standard deviation is a 3. And in a second, you're going to see that these z-scores are directly linked to the percentage. So the further right that z-score is, the higher percent that we did better than other people. So we got two z-scores. If one of those z-scores is better than the other, then he did better on that particular test. If one is lower, then he did lower on that test. But in this case, if you do type both of those in the calculator, you probably noticed, for those of you that have already done it, that you got 1.33 for both of them. So what does that say about these two tests?
They're about the same.
They're about the same. So relatively, he did the same. Relatively, he did the same on both tests. So in this case, it wouldn't really matter which one he would send to the college that he wanted to attend. But if one of them was a lot higher, maybe the SAT, maybe he had a z-score of 2.33, and the ACT, he had a z-score of 1.33. He definitely want to send his SAT score at that point. Okay, he would definitely want to send his SAT score because relative to everyone else that took it, he did a lot better because he's way further to the right, which means there's a lot more percentage that he did better than on the SAT if it were, say, 2.33, for example. So we can compare things that we originally couldn't compare. Okay, we can compare them. We can also find percentages like number 3. So we have a normal population, mean 28, standard deviation 5. Maybe this is age or ACT score or whatever the situation may be. And we want to know what percent are greater than 31. The first thing we need to find is the z-score that corresponds to that number, 31. So we're going to find the z-score. So z equals the number 31 that we're interested in minus the average divided by the standard deviation. And you should get 0.6. Get 0.6. Well, what's that 0.6 tell me? That 0.6 just tells me how far are we away from the average. It doesn't tell me anything about percentage. This chart that I'm giving you is going to take that distance that we are away from the average and convert it to a percentage. This chart is going to be your best friend today. This chart is going to be your best friend today. So 0.60. Why do I want to put the 0 there? I'll explain in a second. We want to put the 0 there because this chart is 2 decimal places. So I want my z-score to represent 2 decimal places. So if there's not 2 decimal places, just add a 0 at the end. If there's more than 2 decimal places, round to the closest 2 decimal places. All right, so over on the left-hand side. So if you look on the left-hand side, all the way down the column, one side is going to have all negative numbers, and the other side is going to have all positive numbers. One side is going to have all negative numbers, and one side is going to have all positive numbers. Find the side that has all positive numbers, and maybe write the word positive at the top, because it does matter what side we look at. We have a positive z-score here. If I were to look up the negative z-score by accident, like negative 0.60,
I might not get the right answer. Flip it over on the back, make sure all the left-hand side is negative numbers, and maybe write negative at the top. You don't have to do that, but it's a good recommendation. That way you make sure you're looking at the right side of this chart before you look anything up. So I need to find 0.60 on this chart. How are we going to find that? Well, that's a positive number, so we need to be on the positive side. The first decimal place is down the left-hand side. So we're going to find 0.6 on the left. Should be closer to the top. And then going across is going to give me the second decimal place. So if it were like 0.65, I would go across to the 0.05 at the top. But this one is 0.60, so I'm just going to go to the very first one. And you should see 0.7257. 0.7257. That's a probability. These are probabilities at the top. See the word probability? Standard, normal, probabilities. But it's really easy to change probabilities to percentages. We're just going to move this decimal 2 places to the right. So that's 72.57%. But does anybody see anything wrong with that? Like, we're trying to find the red. Is the red equal to 72.57%?
White.
That's the white. So what we just found, if you look at the chart, the picture on your paper, and if you also read this right here, it says the table entry, the numbers in the table for each z-score is the area. You can change the word area to percentage, is the percentage under the standard normal curve to the, what's that one word right there, to the left. So what we just found, the 72.57% is actually all of this over here, not the red that we're actually looking for in this case. So how are we going to find the red if we know the white? We're going to subtract from 100%. We got 100% total. Take the white away, and the red is left over. So my answer in this case would actually be 100% minus 72.57%, which is going to be 27.43%. That would be our final answer. So let me circle that in red. So the red area would be 27.43%. So if it's greater than, to the right, this doesn't give me the right. This gives me the left. So you'll always have to subtract the 100 minus what this gives me. Minus what this gives me. There's another way you can do it as well, but I'm not going to tell you. If you figure it out, I will confirm. But there we go. All right, number 4. Normal population, the mean's 39. So normal means we got a bell curve again. On your classwork today, you don't have to draw every single bell curve. I draw them for your notes because it's a nice visual. Like, hey, what are we actually trying to find? 39, standard deviation is 3. So we're going to add 3, and add 3. We're going to subtract 3, and subtract 3, and subtract 3. Hopefully I added and subtracted correctly. And we want to know what percent are less than 34. What percent are less than 34? So 34 is going to be about right there. And we want to know less than 34. So we're looking for that red area. Well, what's this going to give me? This is going to give me the area to the left. So all I have to do is look something up on here. But what are we going to look up on here?
The negative side.
The negative side. We would be on the negative side. But like what number? Well, we got to find the z-score before we can look anything up. So we got to find, like, how far is 34 away from 39 when we talk about standard deviations? And if we look at the picture, we should get a pretty good idea. That's 1 standard deviation away. And that is almost 2 standard deviations. So this number should be really close to -2. Less than -2, but really close. Somewhere between -1 and -2, but closer to -2. So z equals the number in question, 34, minus the average divided by the standard deviation. So this number should be close to -2. 34 minus 39 divided by 3. negative 1.6 repeating, but we do want to round to 2 decimal places because our chart only has 2 decimal places. So does that z-score make sense? Well, yeah, it does. What if I got a z-score of like 2.72? That doesn't make sense because 2.72 would be over here somewhere. All right, we're gonna look up negative 1.67. So you're gonna go down the left-hand side, all the way to the left until you find negative 1.6. And then how we're gonna get the 7? You're gonna go over until you find the 7, and you should see 0.0475. 0.0475. We move that decimal place 2 places to the right to get 4.75%. Do we need to do anything else?
Yeah, you gotta subtract about 100.
No, we do not have to subtract by 100. Because what does our chart give me? Our chart gives me everything on the, and that's what we are looking for. We are looking for what's on the left. We only subtract 100 if we're looking for what's on the right. We move the decimal 2 places because this gives me the probability. And in order to convert it to a percentage, we would have to multiply by 100, which is equal to moving the decimal 2 places to the right. Okay. All right, last one I'm doing with you today. I'm doing number 5, and your classwork is 6 through 13 today. So number 5, let's draw a picture just so we can see it. You don't have to draw the picture in your classwork. I would recommend drawing it in your notes, but you don't have to do that either if you don't want to. 21, we're gonna add 7, and we're gonna subtract 7. So we get 14, 7, and 0. So there's our bell curve, bottom labeled. We're looking for the percent that's between 13 and 24. So what percent is between 13 and 24? So here's 13. There's 13. And here is 24, about right there, somewhere in there. This is what we're looking for. We're looking for this percentage. All right. So how are we going to find that percentage? If we were to look up on our z-score chart, say we're going to do this in just a second, but say we found the z-score for 13. We found the z-score for 13. We look that up on here. We're going to get a percentage. What percentage would that be equal to? Like if I were to shade something in, like what would I shade for the percentage if I looked up 13 on here? It would be everything to the left. So it would be this part right here. Be everything to the left of 13. Is that what we're looking for in our final answer? No, we're looking for the red area in this case. What if I were to do the same thing with 24? What if I were to find the z-score for 24, look that z-score up on the chart, what area would it be giving me? It would be giving me, so from 24, it would be giving me everything to the left. So how can we take those two things and find the red? The percentage for both, and then we would subtract them. So we got the blue percentage. So we would take the blue, that's all of this, and we would subtract, what are we going to subtract? We're going to subtract the yellow in this case. So if we take the blue and we take this yellow piece away, what's going to be left over? The red is what's going to be left over. And that's what we want to do. But we got to find the blue and the yellow percentage first. And in order to find those percentages, we got to find 2. We're going to find 2 z-scores in this case. We're going to find 2 z-scores. So z equals 13 minus, and z equals 24 minus. Everything else should be the same. 13 and 24 is going to be the only number that is different. The average is 21, and the standard deviation is 7. So we're going to find those 2 z-scores. 13 minus 21 divided by 7. Oh, I typed it in wrong. Is negative 1.14. Negative 1.14. And we're going to change the 13 to a 24. So if you already got it typed in, you can just go in and change the 13. And we get 0.428. but the 8's gonna round the 2 to a 3. I need to look both of those up on here. Negative 1.14 is gonna be on the negative side. You should get 12.71%. 12.71%. So the yellow area is 12.71%. The yellow is 12.71. We look up the 0.43 on the positive side, we get 66.64%. 66.64%, and that's going to be represented by the blue area. But what do we need to do with those two numbers in order to find the red? We need to subtract. And we always want to subtract the bigger number, 66.64, minus the smaller number, 12.71, and that's going to give me the red area in the middle of those two, 13 and 24. So when we subtract these, 66.64 minus 12.71, we get 53.93%. So this red area is 53.93%. Your classwork is number 6 through 13 on that same paper.